Today we begin graphing polar equations. We just finished graphing polar coordinates. Now we're going to be using those coordinates and graphing polar equations. Now, these are the classical curves that you could possibly have. Rose, limniscate, limaçon, cardioid, and then this is Archimedes' spiral, also known as the spiral of Archimedes. So when you guys are looking, look for right here. Look at the equation and it helps you identify what's happening. Okay? So right now, I want you guys to look at problem number 2. Look at problem number 2. This is R equals a sine of n times theta. So look at your chart right now and see which one of these it matches. Which one do you think it is? Is it a rose? Is it a limaçon, a cardioid, or the spiral of Archimedes?
Rose.
It is a rose. Okay? Now, n it represents what? What does n represent? A positive integer. Okay? So here's what I'd like us to do. Let's go to the graphing calculator. All right? Everybody at second plus 7, 1, 2. We're going to start from scratch so that you know how to graph these using the graphing calculator. All right, now that you've preset the calculator, you need to get things ready to go. Go to the mode button. Make sure you stay in radian mode. Go over to where it says polar and press enter. Now, if you do that and hit y equals, you see we have R1, R2, R3, R4, and so on and so forth. Okay? Now, when you hit the X button that you used to hit, now what happens? It becomes a theta. All right? So we're going to clear that out. We're going to type in 3 sine 3 theta. We're going to close the parentheses. All right? Then, right now, if you check your table, hit second graph. If you check your table, you see all of these points being plotted. Okay? However, this is theta. This represents your R value. So we're going to make what's called a theta R table. That's going to represent your polar coordinates. We have theta and then R. But before we do that, we need to change the way things appear. So right now, hit second, zoom. I'd like you to turn your grid lines on. Turn your grid lines on. And the next thing after you turn your grid lines on is to hit second zoom to get to the screen. Then I want you to hit zoom and number 4. If you hit zoom 4, you can see your rows the way it's graphed. Now, I want you to take a screenshot of this. Real quick, take a screenshot. I'm going to go back to our very first graph. You guys see how your screen does not look like this, right? So what I'm going to do to help you guys, what's the R value for this circle right here? What's the R value? 1. Then we have what? 2, 3, and 4. So watch this. We're going to go over to our graph, and we're going to make these circles on this to help us with our graphing technique. So watch what I do. Right now, I'm going to go to y equals. I'm going to see how this is red. I'm going to make all of these red. So go over here to where it's blinking. Press enter. I'm going to change it to red. One to the left changes it to red. I'm going to press OK. I'm going to go down to R4. Press enter. Going to change it to red. There we go. And right now, what I'd like you to do is I'd like you to make this R1, this one R2, this one R3, and then hit graph. All right, now that you have this in your graphing calculator, I want to make sure you guys know how to use the graphing calculator to make a really good table. All right? So right now, what we're going to do is we're going to go back to this screen right here. We're going to make a table together. So right now, I'm going to build it with me. I want you to put theta. And above theta, I want you to write DEG, short for degrees. And I also want you to write theta, and right above it, put RAD, short for radians. If you're in the 80s, yes, that would totally be rad, because that was All right, over here put R, which represents which ring or the radius. Okay? Then we're going to make a nice, neat table. I know, we'll just do your best. Okay? Now I'm going to start with 0 degrees. And I'm going to work my way around. 30, 60, 90, 120. So keep going that pattern. Just go up by 30 until you get all the way around. I'm going to go ahead and pause the video and get that done. All right, now that you have listed everything from 0 to 360, now we're going to write the equivalent radians. So obviously, there is going to be 0 pi radians here. 30 degrees, what does that equal to? Pi over 6. 60 degrees? Pi over 3. 90. Pi over 2. What's 120? 2 pi over 3? 150? What do you guys have? 150? 5 pi over 6? 180? It's pi, right? Okay. So we have 5 pi over 6, 6 pi over 6. This is going to be 7 pi over 6. This will be 8 pi over 6, but that reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 does not reduce. And 12 pi over 6 reduces to 2 pi. So every single time you go up by 30 degrees, what do you go up by? You go up by pi over 6. Pi over 6. 2 pi over 6. 3 pi over 6. 4 pi over 6. 5 pi over 6. Sometimes they reduce, sometimes they don't. So right now, I'm going to scroll down and let you be able to take a look at all these. If you want to pause it, that would be a good time. Now, the reason I changed everything from degrees to radians is we actually need to use the radians in the graphing calculator. So right now, I want you guys, right now, to go to your graphing calculator. I want you to hit second window. This is very important. Second window allows you to start your table wherever you want to. So we want to start our table at 0 pi, which is just 0. But if you start at 0 pi, look where you end up. You end up at a what? You end up at 0. So right now, what you're going to do is you're going to write at 0 degrees, you're at a 0. Now what I'll do is I'm going to make all of these green. So I'm going to change all of these points right here to green. Now how do I find out what is the R value when it's pi over 6? What you need to do is go to second window and then you type in second divided by 6. Check your table. And at pi over 6, where are you at? You're at a 3. So right now you're going to write, so basically means at 30 degrees, where are you at? 30 degrees, you're at 1, 2, 3. Put a point right there. At 30 degrees, you are at 3. Now let's check pi over 3. Second window. Pi divided by 3. Check your table. You're right back at a 0. So right here you're putting a 0. Now we're going to go to pi over 2. Second window. Pi divided by 2. Here, I'll pause here just a second. Pi divided by 2. Let's see where we're at pi divided by 2. We're at a? Nope. Negative 3. So we're at 90 and we're at a what? Negative 3. So we've got to go what? We've got to go to 90 degrees. And where are we going to put it? We're going to put it where? The other side.
It's going to be a pattern and then
Yes.
a 0 and then a pause and
Yes, there's going to be a pattern. What you got to take. Once we get to 180 degrees, we can figure out the pattern.
Do we plot the points?
Yes. You're going to plot these points like I'm plotting them. So far I've plotted 0, 0, pi over 6, 3, pi over 3, 0, and pi over 2, negative 3. That's what I've plotted so far. All right, now we're going to go to 120 degrees, which is 2 pi over 3. So I'm going to hit second window, 2 pi divided by 3. Check the table. We're back at 0. All right, so we go right over here, putting 0. Now we're going to go to 150 degrees, which is 5 pi over 6. Second window, 5 pi divided by 6. Second graph, ooh, we're at a 3. So right here, we're at the positive. So we're going to go 150, and we're going to go up 1, 2, 3. Right here. All right? So, where do you think we're going to be at 180 degrees, which is at pi? Where do you think we're going to be? All right. We're going to be at a whole lot of nothing. All right, let's check our pattern now. Now that we've done this, what do we have? We have 0, 3, 0, negative 3, 0, 3, 0. What do you think that's going to be? Follow the pattern.
3.
Try again. 0, 3, 0, negative 3, 0, 3, 0, negative 3, 0, 3. Well, let's see if that works. Is 270 going to be at a 3? Yes, it is. Then we have what? 0 and a what? Negative 3. Because right here, do you see a point there? There's not going to be a point there, right? It's going to be where? Right here. And then finally you get back to 0. So look at your pattern, everybody. Work really, really, really hard from 0 to 180. And then what? Just follow a pattern. Except if you're working with the spiral of Archimedes, because that continues to go on forever and ever. So right now, well, how do I graph this piece-looking upside-down sign, right? How do you graph it? That's where you use the what? The calculator. Now, let's think about this. Watch right here. You guys see right here how this curves? Where's my point right here? At about a what? A 1, 1. I know it's not perfectly at 1, 1. All right, but you're just trying to create this to the best of your ability. So right now, what I want you to do, I want you to create a graph. Looks like this. See the boundaries that I'm using right here? Like that. And there's your graph of that particular rose. Spend the time and energy making a nice, neat graph. Now, from this moment on, all you have to use is degrees. If you have a picture with degrees, just use degrees. Since you have this in your journal and since you have this on your paper, you can easily know how to use the graphing calculator to check to see where your point needs to be plotted. Okay? Just remember, this is your theta, and that's your R value. So when you're plotting, it means you're going to have theta and your R. Okay? That's it.